Hi, today we'll talk about rebuilding the read models, because usually when we have a read model, if everything goes okay, then there is no problem and we don't have to do anything with the read models. But whenever you spot an issue or you misapply the event, maybe your handlers were not idempotent, you need to rebuild the read model. And we'll show you how you can do that and what to watch for. Hi, Tomek.
Hi, Łukasz. And we together today we will start with the code. Yeah, so let's jump into the code now. We have a test where we want to show
Simple
you
one.
Simple one, yeah, where we just want to show you the logic here. So, for example, we have like 3 events: created, completed, completed. For some reason, 2 of them are completed. Yeah, but one
Different timestamp.
Different timestamp. Yeah, exactly. And we want, and then we rebuild the read model. So task view model, if we want to find it, we have like some kind of original version of this read model. And then we have the rebuild method that rebuilds the whole read model from scratch. So basically it should, on the high level, it should like go one event after another from the beginning, from the beginning, and apply it to the read model. Then we remove the old read model and replace it with the new one. So the original read model, let's say, in this place here, will be removed, right? And will be replaced with the new read model. Mm-hmm. And we just, let's say we just assert that the status of both are the same and the checkpoints are the same, right? Mm-hmm. And the simple implementation for that is here. So as I said, we read the stream with events and we apply to the new read model one event after another. Then we set the checkpoint and we find the old read model, we remove it, and we save the new rebuilt read model to the database. And
because there's this important difference between how we handle events regularly and how the rebuild is happening. As you can see here, we instantiate a new object, and then all the changes from the same methods that are used in the handling events are used for and they apply the event to this object, right? Normally, we would get the task view model here, right? If we just applied some new event, and then the event would be applied to this model. Here, there's the difference that we rebuild the read model, right? So we create new object, we instantiate it with an ID, and then, as Tomek mentioned, the destroy and save happens.
Yeah, one more thing here that like in the call method, we just like handling a single specific event that occurred in the system, right? And you might ask now, why, right? Why we want to do rebuilds? So let's jump into the mirror. Yeah. So basically, when you, for example, want to include some new event, excluding event bug detection in the idempotency, right? And when we, for example, change the schema of the read model, and I think that was our recent case, right? That's schema changes in one of the projects, right?
Yeah, exactly. Yeah, and so as you can see, anything you need to do with the read model, that's the beauty of read models, right? You can drop them, you can just remove them and rebuild them, but you need this mechanism to actually perform that, right?
And I think what was also important here, and this in our case, is like it would be easier if we could do some kind of downtime, right?
Yeah,
if we have time for that and so on. But the main requirement here is that we would like to do it in the runtime, right? So all new events can occur, and we want to still rebuild at the same time, right?
Yeah, exactly. So, well, we cannot just stop the application, right? Such a rebuild for large models, or if there is many of them, may take hours, sometimes days. And just to be precise, rebuilding for days or hours, it means that all the read models that we have in the table. I don't mean that just this one task would take so much. I don't know how many events would have to be in the stream. But then we also, of course, have different techniques to deal with that. All right, but as Tomek mentioned, we cannot stop the application, right? So let's consider an example of what may happen during rebuild, because in the simplest case, we start rebuilding, nothing happens. There is this database. We open the database transaction. We delete the current read model, insert the new one, so it's invisible for the user. One important thing is that the version is changed to version 0, right? Because this is the insert of a totally new state. And then, as you can see in the test, right? It's just here with the very same state if we haven't modified the logic or the data or how we apply the event. However, it's rarely the case that nothing is happening, so we need to prepare our code for that, right? And in the case that we draw here is the task is first created, then there's some name change, due date changes, the task name is changing. Actually, this card should be moved in here, but after this event, if we start rebuilding the stream is being rebuilt, and then and during that rebuild, the event might happen, right? Oops, sorry.
Yeah, beautiful.
The event.
Now I get it. Okay,
that's
sorry.
Simplification. That's the async. The event may happen, right, during the rebuild. And as you will see in the code, we fetch the events from certain stream, and then we process them, right? There is still this batch reader that does this in batches, but there is a chance that you will skip this event that happened during the rebuild, and that's our case. And well, we wouldn't like to lose it, right? And in the current implementation, we are using optimistic locking in this task view model table. We explained that in one of the previous episodes, but this is basically just to protect against the situation in which two event handlers try to concurrently update the read model. Okay, let's not get here. In this case, when this happens and we don't have any additional mechanism, so this, I mean, the event occurs when the stream is being, when the read model is being rebuilt, then one of them is going to win. In the test that we prepared, the event handler or the rebuilder actually that finishes first, so that would be this case. This stick is in this model. It would update the status column to completed and increase the version number, right? In the optimistic locking, we increase the version, so the n was equal to 3. Now after this, it will be equal to 4. And what will happen to this one? When it tries to insert rebuilded state, it will use the version 0. Previous version, well, there will be no previous version, but it will try to delete the current read model with version 3, and we'll get active record stale object error because of the optimistic lock. So now we need, and of course, before we get into the solution, the problem is that, well, as I said, the rebuild may take time. We may need to deal with it quickly because the incorrect state may be represented to the user, which leads them to make incorrect decision, or they just try to do some operation that is already performed, so it's not possible to do it again, and the system throws exceptions at them, for example.
In other words, the rebuild costs more than applying a single event, right?
Oh yeah,
so
yeah, totally.
We would prefer to retry, like if we need, we would prefer to retry the applying a single event than retrying the whole rebuild, right, for the task.
Yeah, thanks. And we want the rebuild to be completed. Okay, so as we mentioned, there is the test that is prepared. You can, of course, go to this task app repository and explore it on your own. We'll not go through the implementation. However, these tests is very similar to the one implemented on the sticky notes or displayed on the sticky notes. We also added some logging here so it's easier to understand what's going on. However, as you can see, if Tomek would scroll down the log, the result of the test, you can see that there is this attempt to destroy a stale object error from the active record.
From the rebuild, right? Because that's what we
Yes.
actually wanted to reproduce. So we wanted to reproduce that failing rebuild in the test, and now the fixing of the test would be, fixing the implementation would be to actually to not break the rebuild, but to allow rebuild to finish, right? And then
exactly.
Waiting for new events.
Exactly. Yes. So now to fix this, it could be done in multiple ways, but one way that I initially thought we could fix this would be to add some pessimistic lock. But pessimistic lock wouldn't work because, as I said, we destroy the object, right? So if we destroy the object, and we insert a new one, I didn't manage to do it with the pessimistic lock. So therefore, we decided to do this implementation with advisory locks. You remember the previous implementation? I hope you do. If not, you can scroll back, or you can take a look at the. No, actually, you can see that in GitHub. You have to rewind the video and see it again. Sorry for that. But as you can see here, we added an advisory lock in this in the call method, right? With the one that just simply processes the events, and also.
I think it was like that, right?
It was like that, exactly. So we added the advisory lock in here, and also now you need to go back to the previous version, also in here. We also added the advisory lock in line 41, which is applied. The lock is acquired when we start processing the events. We'll explain why in just a second, but the advisory lock also creates the database transaction. So the database transaction does the destroy and save in the same time, meaning that the user will not see any change. They will not see the lack of the data, right? This is really cool. And okay. So before we explained why the advisory lock is here and not here, for example, right? So we are why this decision for long database transaction. Let's see the test. Let's make sure that it is green, just so you know that we are not fooling you, or do we? It works on my machine.
Yay!
Okay. Okay, so why is the advisory lock acquired when we start processing the events? We were discussing that before the episode. Tomek would prefer, initially before we had the discussion, we mentioned that you would prefer to have it here, right? So in the line 60.
Well, more like thinking about it, right?
Challenging the solution.
Challenging the solution, to make the transaction, let's say, taking less time, but
which is a good thing, right? When we talk about the relational databases, we don't like the long-lasting transactions, but there is a specific reason for that. So the reason here is that we don't want anyone to disturb us during the event processing, meaning that if there is a new event in the stream, there is a chance that even though we have the batch reader, we will not retrieve this event from the stream, so we may miss it, right? And now
I will add it here for a moment, right? So we just to show you that.
In this implementation, we may miss it. And what is the risk? If this read model is not used frequently, then we may have incorrect state displayed to the user. But if this read model is used frequently, meaning that there are any other events that are happening to this specific stream, to this specific event handler that is interested, it wouldn't be that bad, because if you would scroll up, Tomek, we could see that even if we skip the last event, then the checkpoint will be set to one before last, right? And then we will retrieve that last event plus the latest one in this line, right? Whenever we read events from the stream. But that's because we have the projection or the task view model builder that reads this, that builds the read model based on the checkpoint, right? If you wouldn't have it, if you would just apply the events to the read model without checking if anything maybe is left over, then you wouldn't have that. And now I have a cat that is trying to get into the microphone. Sorry, not this time. And she's trying hard. Okay, and then that would be problematic, right? Because we may lose some information. With this implementation, that's not so bad. With the assumption that there is a lot of events that trigger this builder and they are applied frequently. If they are not, well, the user may have some old information which might lead them to wrong decision. So that's why the decision was to do it here. So whenever we do it, if we go back to the old implementation.
Yeah, just one thing that is like, if something happens here, right? I mean, in this specific place. So when we rebuild, we've read all the stream and we were applying all those events. But then if some event was handled exactly in this moment, right? At this this moment, then we will lose one of the events, right? That happened last. So yeah, so that's why we do the advisor log for the whole code here.
Yeah.
And just to be like, one more thing about that, it's maybe not so. This transaction still, we know it will take longer, but still doing other best practices like having short streams, let's say. So we have like for the specific task ID, right? It will not be too much events to process actually. I mean, in general, if we do, like Łukasz said, rebuild for all the tasks, so all of those read models would be rebuilt. In summary, they add, but for the specific task, it will not be too long still, right?
Yeah, exactly. Yeah, so that's one important thing. But always, because there may be some yellow light that this may be somewhat long transaction, as we mentioned. In this case, as Tomek said, it will not be because this read model is designed in the way that it is designed. So it only displays the task. But if there were some external API calls, or you need to fetch the data from somewhere else, you need to process some heavy calculations, whatever, then I would double think about this. Is the long transaction acceptable? Perhaps it's not, most likely. And then I would look for other solution. Of course, first I would write a test that would simulate this specific example just to see that it's indeed a problem and that we can actually, the solution will fix it. That's how we prepared this simple example.
And I think also, I mean, it wouldn't be too bad to have it like here as well. If you are accepting that you can, I mean, you will not lose those events that will happen here. For example, when you rebuild, you will not lose them, right? You will have them. It's like only the read model will be not so fresh, but in the eventual consistency approach, right? You still, at some point of time, you will have like the correct read model, right? Because I don't know, another event will come and will apply 2 events because of this our checkpoint implementation, or I don't know, you like retrigger them again, right? Just to apply some events here. I mean, you have a lot of options later on, right? But
yeah, exactly. There are different approaches for different business use cases. In here, what we really want to show is that how you can use advisory log to rebuild the read model without any event handlers disturbing you or causing the missing some kind of events or making the events being added in maybe different order, right? Because that may be tragic in some cases.
Yeah,
and I guess that's it for today.
Yeah, that's it.
Happy read model rebuilding. See you next time.
See ya. Bye.